Okay, this is 3.4 video lesson and for imaginary or complex numbers. Okay, so let's just open up with an example of a simple solve for x. Okay, and I'm going to go ahead and let this first one be a pretty easy one to solve. We've already talked about this. You learned this last year. But when you're solving for x and you end up getting something where you have x squared equals a -4, you know you're in trouble. Okay. Because when you take square root of both sides, okay, we've got our x, we've got our plus minus, square root of 4 is 2, but the negative part causes us to have imaginary numbers. Now these are not numbers, these are not real solutions, but they are solutions, okay, so we denote this as with an I. Okay, remember that I is equal to -1. Alright, what is I squared? What would happen if I squared this number, squared this square root? It would be equal to -1. So although I is an imaginary number, when you square it, you get a real number, okay? What about if I cube it? I would have -1, okay, for two of the i's basically, times another I, and that's just going to be -I. And what about I to the 4th? Think about it as I squared squared, or -1 squared. That's going to give us +1. Now, you may or may not remember what happens after. Like, let's say you go up to I to the 5th. The pattern just starts over. It starts over like I to the 1. And then I to the 6 is a lot like I squared, and that's -1, and then so on. Okay, we'll explore this in a little bit. You can find I to any power by just using this pattern of every 4th one is 1, and then you can kind of do, there's a few different ways to think about it, and like I said, we'll get to that. Alright, so on this problem, our solutions are plus minus 2i, and if you were to square root either positive 2i or negative 2i, you would get -4, and -4 plus 4 is 0. Alright, think about this. How many x-intercepts does y equals x squared plus 4 have? I'm sorry, not y-intercepts, x-intercepts. Okay, I kind of just solved it out for you. If you get imaginary solutions here, there are none. Alright, so the main idea to take away with imaginary numbers is that they're typically written in a plus or minus bi. Okay, where a and b are real numbers, and so a is just a real number. It doesn't have to be an integer, it could definitely be a decimal, and then b, a real number times an imaginary number, gives us an imaginary, and we call this mixture of the two complex. Okay, alright, let's do another example. Okay, let's say we have, let's do some operations. We have 3 plus 5i minus 4 minus 2i. You may remember this from last year. This is pretty simple. You're just really treating I almost like it's a variable, like x. So this would be 3 plus 5i minus 4 plus 2i, because we're distributing that negative. Combine the real components to make -1. Combine the imaginary components to make 7i. And there you go. Probably you'll see this written where the real number is first. If you wrote this as 7i minus 1, that's not necessarily wrong, but usually we see the I as the very last thing. Okay, let's say we're going to multiply two complex numbers. Let's say we're going to multiply 2 plus 3i times 4 minus I. Now again, you're going to just multiply this out like as if I was just any other variable. So 2 times 4, that would give you 8. 2 times -i, that's minus 2i. Inside would give you 12i. And last would give you minus 3i squared. Now remember what I said about I squared, it's a -1. So that really just becomes a +3. 8 plus 3 gives you 11. -2i plus 12i is +10i. And again, write it where the real number is first and the imaginary number is second. Your calculator will actually do all of this for you, and you were probably shown this last year. Your calculator doesn't really like to solve imaginary solutions, but working with I is just fine. It's the second decimal point. I'm not going to show that to you because you're going to need to be able to do all this without a calculator. But for checking your work, it's not a bad idea to use the calculator. All right, number 4. Let's say we have I to the 23rd. So this is kind of what I was getting at before. If every fourth power, or we could say multiple of 4 as the power, if that is 1, then I to the 23rd should break down, okay, and I'm going to use what I know about exponents. This is the same as I to the 20th times I cubed, all right? I to the 20th, like I to any other multiple of 4, is 1, so I'm just going to cross that off. And then I cubed, if you remember, was negative I. Another way some people like to do this problem is they like to think, okay, I'm going back to this table here, or this little chart. They like to think, okay, well, if I to the 20th is like I to the 4th, then I to the 21, I to the 22, I to the 23, okay? This will not work for any other multiple of 4 because the pattern is in 4, all right? So you can use this, and again, your calculator will check that. All right, let's do another one. Let's now kind of move into the harder ones. Okay, let's say we had 3 plus 5i divided by 1 minus 2i. Now this may look fine, but the problem is that I is like a radical, and here we have a radical in the denominator, and we talked last semester in trig about that being okay for most part. But this is definitely not a simplified complex number. But we're going to simplify this using a very similar technique we used in trigonometry. We're going to multiply by the conjugate of the denominator. Now remember, the conjugate of a binomial is the exact same binomial, but with that middle term, the sign switched. Okay, that middle sign switch. So instead of 1 minus 2i, I'm going to multiply by 1 plus 2i. And I have to do that to the numerator and the denominator. All right, and so let's FOIL. 3 times 1, that's 3. Outside would be 6i. Inside would be plus 5i. Last would be plus 10i squared. And I'm going to go ahead and cross off that I squared and change that to a negative, because remember, I squared is negative 1. All right. On the denominator, I have 1, I have plus 2i, and I have minus 2i. Now remember, this always happens with conjugates where those cancel. Then I have minus 4i squared. Again, cross that off, change that sign. So let's see what we have now. We have 3 minus 10, that's negative 7. 6i plus 5i, that's 11i. Over 1 plus 4, that's 5. And this is okay. But a much better way to write this would be to go ahead and write it in the form that I had on that first page, where we have a real number plus an imaginary number, or it could be minus, but not where it's all over 5. And if you could simplify further, you would, but we can't on this particular problem. I should have put my little... Okay, number 6. This next problem is actually a little bit easier. But students tend to make it more difficult, okay? On this problem, if you're just thinking conjugate, the conjugate of 4i would be negative 4i, but that's not necessary here because of the nature of this number being imaginary and not really complex like the one in number 5. So you really don't have to multiply by negative 4i. That will work, but it will be more number crunching than you really probably want to do. All right, so let's just multiply by I over I and see how this goes. It should work out fine because 4i times I is 4i squared, and that gets rid of the I in the denominator, which is the whole point of this multiplication step. Okay, so 7 times I is 7i, and then 3i times I plus 3i squared. All right, and again, every time you have an I squared, that just changes that sign. Okay, so let's write what we have left. I'm going to write the negative 3 first, and then this is over negative 4, and then plus 7i again, over negative 4, and we'll just clean it up just a bit by writing 3/4 minus 7/4 I. All right, so those are operations with complex numbers. Okay, let's do a little bit more simplifying now, and I'm going to write something on here, and I want you to think in your head or write down what the answer is. Square root of negative 16. All right, now some of you are thinking, I know what that is. That is 4I. You are right. Okay, some of you are thinking, no, it should be plus minus. You're actually wrong, even though you were kind of thinking in the right direction. The reason some of you are thinking plus minus is because of the square root. Now let me go back and show you when a plus minus is appropriate. Go back to the beginning of the notes. When you are solving for x and a step is to square root both sides, including square rooting an x squared, you would need to consider both the positive and negative value for x to be a solution. But when you're just given a square root of negative 16, it's just 4I. Okay? All right, let's do another one. Let's say we had square root of negative 3, and that's it. Sorry. Kind of left that as there was a second part, but there's not. Just this. So you can't take square root of 3. You still need to deal with this negative. Now, you can write this as square root of 3I, but typically you'll see this as I square root of 3. I think just to make sure that make sure you know that the I is not in the square root. All right, let's do another one. Let's say we have square root of negative 45. All right, well, this is just like square rooting 45, but then you tack on an I. Now, in this case, square root of 45 simplifies to 3 root 5, so the way we would write this is 3I root 5. Again, you could put the I at the end, but this right here is how you will see this. And your calculator will not do these. It doesn't really like to do the square root of a negative. It will work with the I, though, but it won't give you an I. Okay. Let's say we had square root of negative 2 times square root of negative 3. So you've got options here. You can go ahead and just multiply these two square roots, get square root of negative 6, or sorry, square root of 6. All right. This, though, this almost seems too good to be true. Okay. So let's look at what these would be individually. Okay, these would be I square root of 2 times I square root of 3. And let's see what we have here. Then we'd have I squared square root of 6. So you would then have negative square root of 6. So which one do you think is right? It's this one. Okay, if you go at it the first way, that's fine, but you need to know that that's going to be a negative square root of 6. Okay, so you'd have to put the negative in. All right, so I know this kind of doesn't sit right with some of you, but these are imaginary numbers, so you have to treat them as such. Just because the negative cancels out when you do negative 2 times negative 3, it was still imaginary numbers to begin with. So this right here is how I suggest you work this. Although there are workarounds to that. Okay, let's say we had square root of 12 minus square root of negative 3. And then we have 3 plus square root of negative 4. You don't, just for the same reason in the last problem, you don't want to just start foiling this out. You actually want to go ahead and deal with these imaginary numbers first, and we want to write this. You can go ahead and mark the 12 as a 2 root 3. I think that would be okay. And then minus I root 3. And then times 3 plus 2I. You could kind of combine these, but it would be a strange number because it would be parenthesis 2 minus I root 3. So at this point, you can FOIL it out. Okay, so 2 root 3 times 3, that's going to be 6 root 3. Outside, that's going to be plus 2 times 2 is 4. We have an I, and we have a root 3. Inside would be minus 3I root 3. And then last we have minus 2I squared root 3. And again, the I squared becomes positive 2. Okay, so let's see what we can combine. 6 root 3 plus 2 root 3, that's 8 root 3. 4I root 3 minus 3I root 3, that is plus I root 3. And you don't want to factor out or anything, you want to keep it as real plus imaginary. Okay, last problem. Step it up just a little bit, not too much though. I want you to solve for x. And here is the equation, x squared plus 4x plus 5. Another way I could have asked you to find the x-intercepts of this function. Either way you look at it, you would always want to try to factor. Now this does not factor. If you're thinking it should, that's because you're thinking the 4 and the 5 are switched. This doesn't factor. So what do you do when it doesn't factor? You use quadratic formula. Good old quadratic formula. Alright, so then I have x equals negative 4 plus or minus the square root of 4 squared minus 4 times a times c all over 2a. Let's simplify. Negative 4 plus or minus the square root of. Okay, this is going to be 16 minus 20. That's negative 4. And then all over 2. Let's break this up into negative 4 over 2 plus or minus. Square root of 4, or square root of negative 4 is 2i. And that's over 2 as well. So my final answer, negative 2. Okay, I'm glad this lesson is almost over because my pen is not wanting to work. Negative 2 plus or minus I. Alright, so I can get this last little bit. Alright, negative 2 plus or minus I. There we go. Okay, bring your questions to class.